RCExplorer.se, exploring the RC world one crash at a time.
Oh crap.
I love flying water planes, and this is a Minimag from 2009. I have a lake really close by, so I thought I would fix it up and fly it. I did take it out for a spin yesterday and I crashed it a little bit.
Oh crap.
So all the electronics got wet, so I think it's time to change it. It was not state of the art at the time, but it was pretty decent electronics. By today's standards, it's pretty crappy stuff. I thought we would do a reversing ESC, so we can, when you're on the water and you kind of get stuck against something, or like, oh crap, I'm gonna get into trouble, you can start backing it up and then turn around. We're gonna do that by using a normal ESC from a Multirotor. We're gonna connect the motor to this, and then we're gonna flash this on the computer to get the settings right. All right, let's do it. So this is a Hobby King SS, I think it is. It is a linear BEC, so they get really, really hot when the plane just sits on the ground. So it really needs airflow. So back in the day, you didn't actually set up the radio using this. You used like a pack of NiCad batteries or normal, like, what do you call that? AA batteries plugged into the receiver. Otherwise you would cook this because it got so hot that it shut down from thermal shutdown mode, which is like 140 degrees Celsius. So it started melting the heat shrink and stuff. Fun fact, switching BECs are roughly a lot more efficient. Say Baby PDB, it's made for the Baby Tricopter. It has a built-in 3 amp BEC, which is switching. All right, so we need a flight controller in order to flash the settings on this, because we're going to set this up as a bi-directional ESC, which you normally use as 3D flying on a quad. We're going to use a pigtail, or we're going a servo extender. That's it. So I'm just going to solder this to signal pin 1 and ground. Now I don't need to do anything more on this because it's powered by the USB. And then I can connect this and I get signal and ground. And all I have to do is power this to get it to be able to flash it. But in order to hear what we're doing and actually test it, I might as well just solder the motor on while we're here. And I have a really good pro tip for you. Get one of these. It's a small bench vise which you can unhook, and it's a ball on there, so you can set it to any angle and then tighten it down. And it has soft jaws on it, so it's sacrificial, so you can change these. So it's very convenient when you solder stuff. And it doesn't really matter which way you're connecting these, because you can change the direction in the software later. Ground wires are usually quite a lot more difficult to desolder because they go to a ground plane, because you need a lot of ground on a PCB. So there's a lot of copper in here which steals the heat, and it heats up the whole board. That's why it takes so much more than the positive on stuff. So be mindful of that. You need a pretty powerful soldering iron, but you don't want it to go high temp. You just want one that can deliver the power, high wattage but temperature controlled, so it can keep up with the demand but still keep the temperature, so you're not cooking anything. So we're at the PC. Apparently you can't use a Mac for this. You can do that with the older one, the LHS, but not for this. So connected to the flight controller. So now it's connected, it's speaking to the flight controller, but now we need to power on the ESC and read setup. Oh, found one, Aikon35. This is awesome. Look at all the settings you get to do. Music! You can put music on it? How cool is that? So next feature is motor direction. And we're going to set this to bi-directional 3D. That means that we can run the motor forward and back, and it's actually really good at changing even in flight. It's pretty darn amazing. This is another feature, non-dampened mode. We're gonna turn that on. Dampened mode is when the motor brakes really hard and that energy is put back into the battery, so it charges it, so it's regenerative braking. We don't want that because we don't want the prop to stop really quick. We want it to be like a normal airplane ESC. I think that's it. I think that's all we're going to change here. Right setup. I'm going to open beta flight here, just so we can test the ESC, make sure everything is working as it should. I'm going to power up the ESC again. And you hear it didn't beep because we don't have, it has to be at 1500. Oh, this does not make me comfortable. So around 1500 is the 0 point. This is where the ESC arms. So if you go lower than that, it's going to spin backwards, as you can see here. So now it spins backwards, and above 1500 it spins the opposite way. Smooth. We'll put it back in the plane and we'll resume from there. So I need 5 volts to power the receiver and the servos, and I didn't have a separate BEC laying around. And this one has one built in. It's made for the tricopter, which has a high-powered servo, and this is easily going to power all the 4 servos, the tiny 4 servos that's in this plane, and the receiver. So we have power to the receiver from the BEC here. We have power to the ESC. Look at this. It's made for it, right? Because I'm gonna pull so few amps through this. This is a 35 amp ESC, and I'm probably gonna draw closer to 8 amps. It's not gonna get that hot. I think we should waterproof it now. So just as we were powering on the plane just to try it out, 2 of the servos, the back ones, had died because there's no drain hole in the back, and these are not waterproof servos. Anyway, so I'm gonna see inside here if there's anything I can... Oh! Okay. I thought it would be moist. I didn't think it would be pouring wet. I'm gonna put in new servos, but I don't have the Corrosion X, like waterproofing stuff. So we're gonna do it with lithium grease and some liquid tape. Okay, there we go, opening. So this is the gear train. So you have a motor down there, and you have a variety of different gears. So you get a very high RPM to a very low RPM, and then you have a potentiometer, a variable resistor in there, so it knows its position. What we're gonna do is just absolutely murder this with lithium fat. Just gonna put some there, and the rest I'm gonna put in the cap here. And this is really good all-purpose fat. So that's a lot of fat, grease. Darn it! I'm just gonna squeeze that out. I think that's pretty full. Use some isopropanol alcohol. It's really convenient to put in a spray bottle. This is gonna dissolve the grease. It works really well as a degreaser. And it's relatively cheap and easy to get, and it's multi-function for like everything. Unscrew it once more. The reason why I screwed it down in the first place is I wanted it to really squish down. Otherwise it wouldn't have anywhere to go if we already put the liquid tape on it. Okay. So I really want this to stick. I don't want it peeling later. So this is liquid electrical tape. So I'm going to put it all over the board here. You don't want to get anything into the pot, otherwise you're good here. You don't want to get anything in the motor either, but it's not as bad. And then we're going to use this as a gasket. I'm going to add it all the way around the edge here. So this, when I put the lid back on it, it's going to squirt out the sides and make a nice seal, hopefully. Really hope this works afterwards where the board's supposed to be. There we go. I'm just gonna really get this on here everywhere because I want to make it a little bit more waterproof on the top too. Be sure to get a lot around the servo wire. You want it to be nice and flexible there. Well, it doesn't look pretty, but it looks better when it dries. Now it's time to waterproof the ESC and power distribution and receiver. To do that, I'm just going to use epoxy. So I'm going to power on, and this is going to be 50-50 by weight. Okay, 3.2. It's going to go up to 6.4 now then. Okay, mix thoroughly a lot, because it's pretty liquid in the beginning, but then it gets hard pretty fast. And as always, you want as much glue on there as possible. You want it to cover everything, so no water can touch it.
Is heat going to be a problem?
In this case, not really. I mean, no, not really, because we're using so little current compared to what this can handle. It's very efficient, this ESC, but if you're going to be on the limit, then yeah, it's going to be a problem. You might need to put a heat sink on.
So is there any way to get this off again?
Yes, you can heat it with the heat gun. When it reaches over 100 degrees or so, it becomes like rubber. You peel it off. I could show removing epoxy from something if someone's interested. Make sure you test everything before you do this. Okay, it's done. It's dried. I mean, it doesn't look great, especially the 5-minute epoxy becomes really yellow. If you do 24-hour epoxy or 12-hour, it looks a lot cleaner. The servos are all dry, and they actually look awful, but I think that's going to work. So we're going to plug them in. Oh, making noise. Yes. They're more quiet than before. That's nice. Good. We're going to put this in the plane now then. This happens to be exactly correct size. It's just funny. Also, it's gonna make life easier as I can move the battery forward and get the CG better. The old ESC was kind of in the way. Just gonna put this on temporarily so I can spin the motor freely. Okay, I think that's good. I'll tape it down a little bit later. We'll put in the servos. Actually, I'm gonna add a drain hole like around here. I'm just gonna make a hole straight through the body. The water can go through when it gets inside of the cockpit, because before it didn't have any place to go. It just stuck there and went into the servos. But if I tip this backwards, some of the water is at least gonna leak out this little hole that I made. Might save the servos or not. I think this is looking rather fine. Okay, so here's a receiver with the coating on it. I did put some tape on the bind button and I pulled that off before it dried. So I still am able to bind this stupid thing. Good tip if you ever need to put on old decals again is push it down. I use a clothing iron. In this case I have a hobby version, and then heat it, because the heat is going to reactivate the glue. It sticks as good or not better than it did originally. We're getting pretty close. We're going to test the ESC and everything now before we commit any further. Nice. Let's see if it... Okay, I'll put a little piece of tape. Okay, I'll take it slow. What I've done... Normally when you have a bidirectional ESC, or if you have a collective pitch helicopter, the mid stick is 0. That's where the motor is completely stopped. And then you have max reverse, max forward. In this case, I don't want to be in the middle all the time when I fly and accidentally hit it backwards. So I added a mix that gives me just positive 50 here. So channel 3 is the throttle. So it goes from 50 to 100, and if I reverse it, it goes from 50 to to 0. So all the way down, and then release it, go to the other way. So you can very easily go forward and back. That's gonna change depending on your transmitter how to set up that mix, but you should be able to make it happen if you don't have a really old radio. That's pretty cool. That it can change that quickly is pretty amazing. So I'm guessing you won't back with 100% power. I might reduce the maximum backing power. We'll see when we get into the water.
I'm at 12% speeds. Don't do that.
Again, cutting it. And this is exactly why you should have the backing up feature. And you can safely return it to home.
Oh, really?
That was hard. And this is why we do waterproof electronics. Yeah, I destroyed the... Oh. So, I think the waterproofing worked, right?
Yeah,
Right?
just don't put it. Don't put the nose up just yet.
Yeah, don't do that.
Nope.
So, yeah, I would say that is a successful flight. Worked pretty good, I have to say. A success. I even did the crash test on purpose. Maybe not really, but it did survive. The waterproof electronics held up. The servos are still working. And the backing feature is freaking fantastic. And it's so smooth, the throttle. It's just, you have so much more resolution compared to the old 8-bit speed controller. This one has a dedicated hardware PWM output and a lot more throttle steps. So even though I'm just using half of it when you fly forward, you still have so much more smoothness. Now I do know everyone in the comment section is going to be wanting... I know everyone in the comment section is going to be like, oh, why don't you try it in mid-air? Because I think that would be super awesome too. But we ran out of time, and I think I need to change the prop, because the 8-inch prop I have on here now, it is pretty perfectly... Oh, I shouldn't have done that. It's made to be super efficient, so there's not a lot of headroom, because I get like, what is it, like 15 minutes? 20 minutes least, on one flight, on one 3S 1300. I might do a video where I do reverse stuff in midair. What do you think? Just gonna let people comment and let me know. Anyway, thanks for watching. Hope to see you next time. Wanna go
Click the subscribe button.
Oh yeah. Click the subscribe button, like button, share it with your friends, and
the little bell. Don't forget.
Oh yeah. Why is there so many things you have to do these days? It's like, oh my gosh. Anyway, thank you for doing all that.